Okay, let's do the AC analysis for mid-frequency. Okay. So for the circuit on the left, we will draw its mid-frequency hybrid pi model. Okay, and then for the right circuit or circuit number 2, we will also draw its equivalent mid-frequency according to using hybrid pi model. So for during middle frequency analysis, what happened to the capacitors? Okay, C1, C2. What happened to the capacitor is that, okay, the reactance, the capacitive reactance, or we label it as XC, okay, the reactance will decrease, so the current can flow, or this is just a simple note. Okay, so we have the equation at C equals to 1 over omega C, and then we know that omega equals to 2 pi f. So when Xc decrease, okay, the current can flow. Therefore, we represent our capacitor with a closed circuit. So if we have frequency value starting from 0, we know that the frequency will increase. Okay, increase. Okay, starting here. Okay, starting from here, we at a certain range of frequency, we label it as low frequency, and then up to a certain value of frequency, we label it as middle frequency, and then as the frequency increase, okay, we represent it with high frequency. Therefore, during middle frequency, okay, since the reactance goes down so that the current can flow, thus we represent our capacitor with closed circuit. Okay, so this is closed circuit, or we normal term is short circuit. However, short circuit is not mean it is broken. Okay, it means it is closed. Alright, so let's draw the hybrid pi model during mid-frequency analysis. For circuit 1, okay, here I like to remind, we label the BJT terminal CBE. Okay, here also CBE. Okay, arrow is at emitter. Okay, and then we need to know where is the input and output of our circuit. So here the input is at the base. and the output is at the collector output. Alright, so same for circuit number 2. The input is connected to the base terminal. It is over here. Okay, so the output is at the collector. Okay, so next step is to draw the hybrid pi model during mid-frequency. So firstly, I like to draw the input on the left and the output on the right. Okay, so we label input and output. So the input is connected to base. Okay, the output connected to C. Alright, and then the emitter is over here. So we know that from base to emitter we have R pi and also V pi. And then at output to emitter we have a current direction. Okay, so here what we can do is we see the arrow. Okay, the arrow is pointing to emitter. Therefore, our arrow for the circuit is from C to E. So we need to label GM V pi. Right? And then we need to determine what is the type of our BJT. So here, since the arrow is pointing to emitter, we know that the base is positive and emitter is negative. Okay, so this is NPN BJT. So NPN means base is positive, so base we label V pi as positive at the base, emitter is negative. Okay, and then we complete our circuit at the base over here. We have R1 and R2. Okay, before that, for AC analysis, okay, the DC source, we represent it as ground. Okay, so the VCC here we replace it with ground. Okay, therefore at the base we have R1 and R2 connected to ground, and this is also connected to ground. So at the base we have R1 and R2. So I erase this first. Okay, R1 and R2. And then we have connected to base is RS and also VS. RS and VS. Okay, so we complete at the base part. And then we see from our emitter here, we have RE. Okay, so we need to draw RE. RE is connected to ground. And then at the collector part, we have a resistor RL and also Vout. So here at the C, we have RL and also we have Vout, positive and negative. There is another resistor over here, RC, okay, from the collector to here is ground. So here RC, okay, you see RC is before the ZI. Okay, therefore before ZI, Z out, and you see the RL is at the back of the arrow. Thus, what we can do is we draw RC before RL. Alright, so at the collector part, we connect to RC. Okay, and then we have Z out. Okay, and then we have another ZI over here pointing to base. Okay, so this is the AC equivalent circuit during mid-frequency by using hybrid pi model for circuit number 1. Then what happened to circuit number 2? Circuit number 2. Okay, circuit number 2, we can see that the circuit quite similar, except there is a capacitor over here. Okay, so we know that the CBE, the input, the output, all are the same except at the E terminal. Okay, so at the E terminal, what we can do for circuit number 2 is, okay, for circuit number 2 here, at the emitter is connected to a capacitor and also a resistor. So during mid-frequency analysis, CE is closed circuit. Okay, so therefore we can see here at the emitter part, okay, this is RE and the CE is closed. Okay, so you can see that the circuit, okay, the circuit is directly connected to the ground from emitter. So from the emitter is directly connected to the ground. So we can do a bit modification for our hybrid pi model here is, okay, same input at the base, output at collector. Okay, emitter, this is R pi, V pi, GM V pi. So at the emitter is directly connect to the ground. Okay, this is circuit 2. So we need to draw everything, all of the other components, since it has the same configuration. So I just redraw it over here. Okay, this is V out, Z out. Then we have R1, R2, RS, VS, and also ZI. Alright, so that's it for mid-frequency analysis using hybrid pi model. Alright.